Good morning, class. My name is Mr. Burns, and today we'll be discussing velocity and acceleration. Now, the thing you have to know about velocity and acceleration is that they're pretty much the same thing, however acceleration is just a bit faster than velocity.
Oh, Mr. Burns, that's not right. You see, velocity is when you take a distance over a certain period of time, and the standard unit would be meters over seconds. However, acceleration is when you take velocity and measure that over a certain period of time.
Oh yeah, go sit down. Anyway, class, we're now going to go on a field trip to learn a little bit more about velocity and acceleration.
Let me record you. You got a little tired. Stop.
I am now going to give you a quiz.
Well, teacher, you sort of went fast in the beginning, and then you just stopped, and then you accelerated. That was yours. Whereas me, I just went at a constant velocity the whole time.
How fast were you going now?
Well, you see, I was going 10 meters for 20 seconds, which would make me have a velocity of 0.5 meters per second.
Very good. Now class, if you throw a ball on top of a hill, it will go farther than throwing a ball on the ground.
Well, actually, from my understanding of it, when you throw a ball on a cliff, what the ball really does is go down with velocity, constant velocity, and gravity going down this way. So therefore, you cannot throw it farther on top of a hill than you can on the ground. Why don't we go take a look at this outside?
Alright, sit down. I suppose we could go on another field trip for more information about this.
Ready, shoot. 10 meters. Shoot it. 10 meters. What did I tell you?
Good morning, class. Today we're going to be discussing centrifugal force. Here's a demonstration. As this box comes out, centrifugal force will push this box out as I spin.
Ah, Mr. Burns, once again, as this object is moving in a circle, it's actually accelerating. That's called centripetal. Well, see, Mr. Burns, what really happens is when you have an object like this, for example, and it's going a certain constant velocity, when it's spinning and turning direction, it actually forms sort of an acceleration. And what it wants to do is because it has all that speed, it wants to break out and go straight. See, Mr. Burns, the equation for centripetal force is centripetal force equals mass times velocity squared over the radius. So if we have 0.5 kilograms, 0.5 velocity squared over radius, we get 0.25 newtons, which is the actual centripetal force. Now, centrifugal force is the perceived tendency of the force going outward, but centripetal force is the real thing.
Oh boy, I really had a lot to think about. I don't know what to say. It was wonderful having you in class. You really taught me a lot. A shame. I really didn't teach you much this semester.
Ah, don't worry, Mr. Burns. I had a great time in your class teaching you physics. We both had fun. Remember, physics is fun.
Don't worry. Join me next time in class and I'll prove you that lighter objects have less gravity than heavier objects.
Oh, Mr. Burns.